All right. Hello, everyone. And welcome to our talk. This is my colleague, Olivier, and my name is Hugo, and we are working on the elef.im project, and we're here to speak to you about the InterPlanetary virtual machines, so using IPFS to decentralize backends. As the Free Software Foundation Europe quotes very well, there is no cloud, just other people's computer. And if we are moving more and more towards using other people's computer, we better choose whose computers we're using. And this is also something that's really happening a lot in the Web3 world, which we wanted to illustrate here. So two people, hey, have you heard? I heard you're making a decentralized apps. Yeah, no central authority. It's all open and public. People can log in with their decentralized identity, use tokens, and we trust the giant US corporation with all the servers and the data. Didn't you say decentralized and no central authority? Doesn't it still count as long as users need a wallet to be a Web3? So we're trying to change this state. We're talking with a lot of projects, and very often what's happening is you have the Web3 apps, and then they have a wallet, they use a blockchain, and then they use a cloud hosting provider. To illustrate, we had, if you remember, more than like 15 years ago, we could get software on CDs, and it would work all the time, and every time you plug the CD in the machine, you can just use the software, you don't have to think about it. Then things moved to the very common LAMP stack or other versions where you have Linux, Apache, MySQL, Python, PHP, Perl. And that moved away in usually sysadmin managed servers, manually managed servers. That moved more and more to cloud, and it's still the main system used at the moment. And then on Web3, yeah, we still often need a backend. So now, small poll here.
So yeah, I have a question for you guys. First, who here has built a decentralized application? Okay, 6 people, not bad. And then next question, where did you host your backend? If you had a backend. Okay. Yeah, that's what we figured. Basically, our main question regarding your backend is, what guarantee do you have that your application is going to work in time? The main issue is that, as Hugo mentioned, people used to deliver software. If you wanted to use your software 10 years later, there were still ways to do it. Today, with a cloud application, where your cloud backend, if your application is still, if you can decommission it, or worse, if Amazon or Google decides to plug it off, well, it's gone. Basically, first, you can't use the application anymore. And worse, your data, your personal data is probably gone with it. And yeah, basically, we all tend to think that those giants, are there forever, that they will stick around, that they will always be there to provide the service we really pay them for. But the truth is that Web2 applications can die. And we have examples of some dead and not yet dead projects. But yeah, basically, those applications will come and go, and other applications that we use today will come and go. That's something that we try to stay away from with Web3, with decentralized applications. I think we want to build something that can last a bit longer than this. And yeah, that's the whole issue here. We also have this issue in Web3 itself. I think a common occurrence of the problem is NFTs in general. That people use the blockchain to store NFTs, and they're like, now you have an immutable store of your title of ownership for a picture, for anything, for a house maybe in the future or anything. But if at the end of the day you use a simple URL beside to store it, you still depend on the underlying service. That's what happened a lot. That's where IPFS has a really nice use case as well for this kind of stuff. So we have a solution for data. And our main question is, okay, if we have a solution for data, could we have a solution for programs?
So the goals we would like to achieve are, we're looking for something that's easy to use, compatible with most existing stacks and software. We don't want to reinvent something else, a new GVM or something. We want something performant, fast, low latency, where it's easy to offer long-term guarantees. Even if the developers stop working, maintaining something, you may have heard about these video games where at some point the company decided to went bankrupt or just decided to stop supporting the project, and because the game requires communicating with the backend to work, you just couldn't play the game anymore. We want to make it easy for users to take over paying for the hosting, paying for the backend, taking care of that if the developers stop working on it. We want something, of course, secure with sign updates, confidentiality of user data. We want to have ways to verify the content, to authenticate that it's the right content. And we're looking for something that's distributed. So we don't want a platform where any single entity has control over the whole system. So that we have something truly decentralized, where everyone could add their own parts to it. In a similar way with IPFS, you can host your data on IPFS, pin it on Filecoin, pin it on on ELF, on different services, and you can pin it on every service at the same time if you don't trust any of them that much. It allows you to distribute this trust as well. Now, if we look at the existing ecosystem of things we can use that are decentralized, so we have blockchains and off-chain databases that allow things like authentication identities by using cryptographic keys instead of using usernames, passwords, putting everything in a database that's run by a centralized party. Using cryptographic keys allows us to remove that part and get the login part outside of this central element. And then we also have the support for transactions if people want to transmit something to someone else or to run any kind of transaction, including payment. Blockchains are a good solution for that. And yeah, it stores also this problem of no password to steal. Then we have large file storage solutions. For example, IPFS, but also BitTorrent in a way. They help manage and share large files. They're decentralized and peer-to-peer. However, there is still this issue that there are technology they still require peers to actually store the files. It's quite easy to publish apps on IPFS. If you're using web technologies, you can publish just static pages or single-page apps written in JavaScript or anything that run on WebAssembly. Or you can just use it to upload mobile apps, and users can download mobile apps directly from IPFS and run it on their phone. That also decentralized in its way. Another technology that is very useful is virtual machines and containers. So there are two kinds of virtual machines that we speak a lot in the space. There are the chain virtual machines that execute smart contracts on chains. And these are limited on purpose. And they're not used for general purpose computing, which is what we're interested in. And then on the other hand, we have system virtual machines like QEMU, Firecracker, that run an entire operating system. And this means that they're compatible with all the apps that can run on these systems. And then we have containers that allow, with Docker leading the idea of reproducibility and auditing. But if you look at how containers run in the clouds, they almost always run inside VMs for security reasons, for isolation to the other workload. So usually only containers from the same user entity can run within the same virtual machine or system. So at the end, if we summarize, we have storage execution, we have on-chain and off-chain. So for storage, we can store data in transaction, very small amounts. We can store it off-chain with IPFS and pinning. And for execution, we have smart contract when it's off-chain, but when it's off-chain, we don't really have like an easy solution that solves the issues we were presenting.
Yeah, so let's have a look now. Of course, we come with what we think is a solution. And yeah, let's discuss a bit more the technical requirements that we think could be nice. We called it InterPlanetary virtual machines for the sake of the speech because, well, we needed a cool name for the presentation. But yeah, they're regular virtual machines. And let's see what do we want inside them. So basically, first, we want Linux systems. Like, I think, if you want to build a new decentralized cloud service, we're going to want a lot of developers. We're going to want people who are used to web technologies in general, not only blockchain technologies, who are not necessarily smart contract writers. People who can just, whip out any application, JavaScript, in Python, in Rust, anything familiar. We don't want to disrupt this. We also want some kind of permission-based composability of file systems, basically. It's going to be important because, for example, well, you have root file systems. If you get into virtual machines, you have lots of disks of file systems of way to compose this. You want file systems that are read-only, read-write, that are stored, that are not stored back once the virtual machine dies. Well, you have a lot of variabilities there, and basically we want a composability there to link all those file systems, store them all on IPFS, so that we can just pull, for example, the root file system. Like if you want a Debian file system, you can pull it from one part. Then you can have your application that will live in another file system. And you can also have a disk for like your configuration, for your data, for your application. You can really compose things there. And as Hugo mentioned earlier, we also want to, well, use the cryptographic keys that we use in crypto today to sign image, to secure the update procedure so that only the original application maintainer can update his own code. If you want to fork it, of course, that's fine. But we have a way to identify who maintains and updates the application. That's going to be really important for users, of course, because we want to trust the application producer. We want to know that, well, we can trust this version. It has been signed by the original author. There's no issue there. Also, speaking about the network itself, because, well, we're going to need a network to run all this. The traditional way to do that now in the space is to have networks like of validator nodes, networks of execution that are going to work together, that are going to need to be incentivized, because, well, someone has to pay for servers, for computer time. And yeah, basically we need a way to make funds go from the end users directly to the servers, well, or the node providers. And at the end of the day, of course, if we incentivize, we also need a slashing mechanism to punish rogue nodes, to ban nodes from the network, to recuperate, to have a self-healing system in the network, so that if, for example, someone operates a node that will run virtual machines and, well, tries to mess with virtual machines, his machine is banned, and all the virtual machines that are supposed to run on its node are rebalanced on the network. And that's basically what we aim to do here at ALF. So I'm going to discuss a bit more what we do and how we present it. So first, feature-wise, let's maybe dive into the meat of it. Today, we really have Lambda functions that you can use for any type of serverless functions that you want to run on our network. We also have persistent VMs, like, for example, if you want to run a database, if you want to run a CI/CD server or some of that kind of stuff, that can be really run in a persistent manner on the network. And this is all managed by messages that you can sign with your crypto wallet. So basically, you send a message to the network with your crypto wallet. This will trigger, in turn, the scheduling of a virtual machine that will either run your application or call other applications. And so, yeah, how does it work internally? So we have this validation network. We have a network of nearly 75 what we call core channel nodes that will take user requests. That, for example, when you want to create a new VM, what you will say is sign a message, send it to the validator network. They will verify that you have the funds, that you have everything that you need to create this VM, schedule it, and transmit it to our second network of what we call compute resource nodes, which are basically just the executors. Those nodes are only in charge of running today Firecracker and basically schedule VMs. Yeah, so that's the only thing they do. And just another note on something that's coming really soon that we're quite excited about is confidential VMs as well, because one of the issues that we face, of course, is that node operators technically could access this, the data inside virtual machines. We have found ways around this, and we're going to release something about this very soon. So, yeah, that's...
So, and in the design, we really have this way that when you publish a specification to run a certain program inside a specific virtual machine, these messages are public, so anyone could say, okay, I want to run the same program in a virtual machine that I control. So it's also this idea to give control to the end user. If they want to fork any existing program, they can just do it, of course, if the license, there is still copyright that is allowed, and the author of a VM or of a program can always add checks to make sure that only the people he allows run it. But we believe in open source, and all of our software is entirely open source and decentralized. The ALF doesn't control most of the nodes, and we really want to have something that everyone can take part of and that's completely open and transparent. So that's the end of our introduction about the virtual machines of ALF.
I have a question. You said you support Lambda functions and virtual machines. Where do the Lambda functions run? Do they spin up inside a VM somewhere?
I think it's, so we support calling using virtual machines in two different ways. You can either call them on demand, and we're using micro VMs that don't emulate an entire system, so they start really fast. In less than half of a second, we have the results of a simple computation or simple call. Or you can schedule a persistent virtual machine and say, hey, I want this program to run all the time.
Quick question for you guys. Love the architecture, by the way. I think this is exactly the kind of discussion that we need to have more, because a lot of people are trying to solve these problems. How do you feel about on the market making side or the pricing side for resources when the VM gets invoked through smart contract? Do you have any intentions about making pricing be sort of static or somehow dynamic based on availability? Any thoughts you have there would be super interesting.
So we haven't finished the pricing yet, but what we really want to do is something that adapts to the real costs of running the service providers at the end. We also want something that can basically, we want to be able to compete with Google Cloud or Amazon that you used, and be able to provide a similar pricing for our users. So that. And at the moment, you cannot launch the VMs with smart contracts, but that's something we're looking at. We also we don't have our own chain. We're using tokens that are cross chains, and all the messages that users publish on ALF, including to schedule virtual machines or to add configuration, to store data in our distributed database as well. That's another topic. We allow signatures, and we support addresses from many different chains, which really try to be chain agnostic, so that it's not using one chain or another. And we're also working. We had a talk at the Solana Hacker House this morning by a colleague of us on a project of indexers. So we are also working on using this infrastructure for indexing chains with a lot of data. And then one of our projects soon is to link the two and to make VMs, Python virtual machines that run based on something happening on chains.
One last question, if you don't mind. On the networking side, did you run into any issues with gas accounting for these transactions? Do you sort of prefer networks that maybe have lower gas fees, or does that become an issue with just the communication across these transactions? Have you ran into any concerns there?
So the messages that schedule the VM, usually they're launched by creating messages on our own distributed database where we don't have gas fees. However, they're also archived, so that database, we want to provide guarantees that a certain message has been published at a certain moment. And what we do is we archive a bunch of messages all together, and we pin this archive on IPFS, and we publish this CID on chain, and then in these we use gas. We're doing it on Ethereum. That's quite expensive. We're almost doing it on, we are looking into doing it on Solana and other chains as well, where the gas fees are lower, so we could do this much more often. And in terms of gas fees, we also have to reward the node operators. So we also have gas fees there when we're sending the rewards to everyone. So yeah, we do face gas fees in some different places, and there is definitely a difference between using one chain or another there.
Yeah, sorry, I'm curious about the privacy and the protection part, because I see now you're basically doing this lambda function, right? So is there anything, it can be binary or something like that? So it's running on open public computer. So have you think about give people the customized code building process or something like that? And also the data, for now I see because on public data, computer, where the data be protected or not?
Sorry, I'm not sure I understood.
The data is on IPFS, so it's not encrypted, right?
That's right. Yeah. So if you're building a D app, for a web app that's using ALF under the hood, you have two options. You have to say, okay, we store the data on ALF. Maybe we use virtual machines to do some computation on the server side. And then it's the user's wallet, the user that's decrypting the data. We have our SDK provides encryption and decryption methods using the standard ECIS. And so either you trust the user to decrypt the data and everything is encrypted on the network, or you will be able to use the confidential virtual machines that are using trusted platforms inside CPUs. That mean that the operator of the server itself, even with the root access, won't be able to access the secrets stored inside that VM. And so that will allow you to have server-side virtual machines that do access secrets in a secure way.
Okay, so basically it will be something like SGX.
Yeah. We're using AMD SCV first because it's more adequate for virtual machines, but it's basically the same thing, just implementation details.
Okay, we'll give them a big round of applause. Thank you guys so much.